Hi, welcome to this video on my Raspberry Pi, where I still try to do the LED play with Python versus C++. Last time I tried to do the Pi GPIO test to test the GPIO for the Raspberry Pi 2, considering all the very weird results on the LED play, the LED play. And in order to do the test, I have to know which pins I actually should test. So looking here, I should test on pin 7, 12, 29, 11, 16 and 31, which, as you may notice, is not exactly in the correct numerical order, but I don't care about that for now. The GPIO numbers may come later. Another point is that what I noticed is that for the Raspberry Pi 2 some exceptions are for pins that are writable. However, I think that is not important now. So what I want to do is see if I can start within this directory the daemon. The daemon is the server which actually enables the testing. However, if you have watched the last episode, it didn't exactly go right. I should be able to say sudo and that's it. Let's see if this worked this time. Nope, because this library is not there, or so it says. Well, it clearly is there. So this is a problem, and I have to find out why this is the case. When I do the same on the Raspberry Pi 1, so let's just do that. And you see, nope. Wait. I did it different here. Command not found. So, oops, that's wrong. So, when I look at the daemon, it is executable, and when I look at the daemon here, it is executable. The GPIO the library is also executable. Going here, here's the library, also executable. So why is it not functioning? The same problem I had last time. So let me once again try to find out what the problem is, because without it running I can't test the GPIO. Sometimes it is better to actually read an installation manual. So now I managed to install and get the daemon running. As you can see here, no error this time. And in the process of finding out, I also find a program called RPi, and that is supposed to show all the actual inputs and outputs on the pins. So while that is true, I first have to put the band cable back to the GPIO, run sudo let's see, and let's go back into history. And here we have the whole pin out. Which, according to everything, is a live picture. Although when I look at the pins that I'm using, 7 is this what I expect to do? Well, right now nothing, just because there's nothing running. So let's see how this works out. No, okay, I will stop this. Because what I need to do, although it's a very nice graphics, there's nothing here. So I will use the ampersand. In Unix, the ampersand makes sure that a program will run in the background. So this is what it does. Right now nothing. So I go back here and I say okay, sudo GPIO LED version 2, and there you go. And you can actually see what runs and what doesn't. My question is though, is this the GPIO numbering or the pin numbering? And that is a very good question. Let me, how can I do this best? Pin 7 is GPIO 4 and pin 12 is GPIO 18. They are using the GPIO numbering. And that would be GPIO 5 as well. which I don't see happening yet. GPIO 6, not happening yet. Here's 5. And 17 is not happening yet, but 18 is. So they are definitely using the GPIO numbering. This is interesting. So there is actually not really a need to test the GPIO. And another thing is, when I start the camera, you can actually see the LEDs go on and off. Let me shield them from the light. Not easy to see. But you may see it. And while this is running, I will do exactly the same, installing PI scope on the Raspberry Pi 1, because this is a very nice program to actually see what happens and when it happens. So yes, nice idea. So with this on the RPi2 side, and this on the RPi1 side, and let's also start running the program on this side, and here you can nicely see the changes in the status. Here, by the way, just as well. And now the question is, how did you respond? Looking at the code, with all if statements out of it, it just runs. And the same you can see here. All if statements have gone out. So with this situation, I'm going to bring back the ifs step by step. Another thing is, and that remains the point, they are not running at the same pace. I've started this a while ago on the RPi2 side, and when I just start this on the RPi1 side, that is going to give a problem because they don't wait for each other. And I'm very curious to see how this behavior will change. So for now, let's cut this, and let's cut this. Yes, and you can now clearly see that they are all off thanks to this mechanism I brought in last time. Try accept. So when I press Ctrl C, it cleans up the whole GPIO. So let me bring back, oops, the if. And this is on this side, and let me save this, and let me see what happens if I let's see, yes, and when this one runs, the second one here should be running. So okay, let me write this, and then I'll have to compile. So with all the commands done, I'll have to find the, and this is it, compilation. Yes, it works. So this is 1 and 2, and now let's see how everything works out, if it does. Yes, and another point is, of course, I have to keep in mind that this is the GPIO numbering and not the pin numbering. So that is for me a bit confusing, let me put it this way. So I have to think here GPIO 17, which is this one. It is not pin 11 but pin 17, and also because this input state 11, which is this one, and GPIO 18, so 17 and 18 I have to keep a look at. And what is this one doing? This one is looking at, that's another point, I haven't put the actual GPIOs in, and so that is going to be totally confusing. This is a recording anyway, showing live data and recording. some kind of oscilloscope. But let me end this, and let me end this. I should be able to play it. Although I don't find that it actually plays. Okay, I guess I'll have to find a way to do that. Show live data, which is nothing because I stopped it. New things always go a bit, can go a bit wrong. Okay, let me do it once again, but this time with all the pins also in at the RPi1 side. Could make it less confusing. Another thing is that I started the whole diagnosis for the Raspberry Pi 2, which led to install PiScope, because the LEDs on from the Raspberry Pi 2, being these, didn't work at all last time. Whatever I did, they did nothing. As you could see, they work again. So whatever was wrong, and last time I even completely rebooted the Pi 2 without any result. So whatever that cause was, I have no idea. Right now, as you can see, I have removed all command brackets, so the full signaling is out there. Also compiled and ready to go. Going to the version 1 site. For my hopefully less confusing ideas, I put the GPIO pins here, and all commands are removed here as well. So this is ready to go, and this is ready to go. Let's see what happens. I still think that the the CPU speed and memory difference matters. So that will probably be giving some weird result, but let's try anyway. Let's first start this, and then this. And as guessed, nothing works. Let's see here. Nothing at all. Here. Absolutely nothing at all. So, although the LEDs prove to be working, they're not waiting for each other, period. And let's end this for now. The schematics I had drawn show that the first two are dependent on each other, which indicates that GPIO 17 goes to GPIO 18, pin 11 goes to pin 12. So what I can do to get at least a little bit of stuff working, 16 goes to 29, but there's nothing I can do right now on that. 31 influences 7, but let me put this out for now. Only 11 does something, and this is on the RPi1 side. Oops. On the RPi2 side, I have 7 influencing 11. For 7 on the RPi2 side, influencing 11 on the RPi1 side, and 7 is GPIO 4. Which is here. So I should probably say this goes out. Although not quite necessary. This the if should go out. And then also this if. And then I let this just in, because GPIO 18 is influenced by 11, so this should be alright, and this has no use at all. But I'll let it in for now, see what happens. In some way, sometime, it should go fine. Compile. And once again, compiling doesn't say the algorithm is working, it just says that there are no syntax errors in and no C++ grammar errors in whatever way. So let's see whatever happens now. This is a different result, but I don't see anything here yet. And 31 is GPIO 6. Nothing to be seen. 11 is GPIO 17. Nothing to see. Let me go here. Ah, that's a problem. Hold on, I didn't check that. Okay. What did I do? Line 42. Ah, see. Typo. Alright, try again. do I see something happen? Well, here I do. Here I do too. Going up, going down. Do I see something here? Just nothing at all. A very one-sided thing to do. Up, down. Okay, very one-sided, and I'll let this run and go to camera to show you what actually is happening. So, with the current setup, you can see that these two LEDs are working, while this should influence this one, and this one should influence that one. So as said, the LEDs on this side are working again. Perhaps I should activate this one as well. Are they actually activated? Yes. It's not entirely what I intended, but these ones seem to go fine. These ones seem to go fine. But is this what I intend? Looking at the PI scope, which is still running on the RPi2 side, nothing happens, but on the RPi1 side things do happen. Is this logical? Perhaps, but given circumstances it is just another interesting experiment, and step by step getting closer to what I like. So let's go back to screencast. So, with at least the proof that the hardware on the RPi2 side is not broken, a nice tool installed, LED play is yeah, not quite what I intend to achieve yet. LEDs still going somehow. I have to improve the code, and at least here you can see how things are working. I am quite curious why it's not working on the RPi2 side. That will have to do with the programming, I assume. So I'm gonna leave it this way. Thanks for watching, and to be continued.